Hello and welcome. In this video lecture, you will learn how to organize your files into a library and how to add keywords highlighting and how to add examples. You will also learn some of the C++ object-oriented programming basics such as constructors, access specifiers, static methods, and separation of implementation from header file. Let's get started. So we start by opening a new empty sketch file and then save the file by typing Ctrl S, give it whatever name you'd like, and afterwards let's close the Arduino IDE and then let's open the directory where the sketch is located. It's usually located under Home Arduino. Let's click into that directory. Here we can see the INO file, the sketch file. Or simply right click and open a new terminal. If you are on Windows or Mac, you can simply create a new empty text file. And then I'll start by typing my library for the header file, an empty text file, and once again for the implementation file, that my library.cpp file for the C++ implementation file. Enter. And now we're done here. Type exit, and then I will start Arduino IDE once again. What we have done here is that we have created two empty files in the same directory where the sketch file is located. Opening my Arduino IDE, you can see here that we have got two tabs for the new empty files we have just created along with the same sketch file that we started with. So basically the idea is that you can add as many files as you like to the same project by using the same trick. Now let's go to my library.h, the header file, and then we start by typing some directives, hash f not defined, my library header file _h. So we are instructing the compiler that if this file is not included, is not defined, then start by defining it. Hash define _my library _h, and then finally we have to close the if condition by typing hash end if. So this is a clean way, a best practice to include your header files in case the compiler tries to include them more than once. Now let's start defining our class by typing class my library and then curly bracket. Remember to close the class definition with a semicolon. C++ introduces three access specifiers such as public, private, and protected. This is common in all programming languages that use OOP or object-oriented programming. Public simply indicates that the method or the property of the class is accessible by all other snippets of code in your program. The private is the opposite. Nobody can access it unless it is in the same class. And then protected is accessible by the classes that inherit from this class. For this exercise we'll use public, so we type down public colon, and then we define the constructor my library. So the constructor takes the same name as the class, and then it can take as many parameters as you like or no parameters at all. These parameters are used to initialize the class when instantiating an object of that class. Now let's define the same method that we have discussed in the previous lecture to do the decimal to binary conversion. I will define it as a static method so that we don't have to create an object of the class in order to use it. That means the method will always be available on the class without creating any object. We can do that by typing static and then the method definition. For brevity, since we have already discussed the method internals in the previous lecture, I will simply copy and paste the code for the method in here. So I will simply copy the code for the decimal to binary method from the previous lecture, and then I will add it here, and then I'll make sure that we have got the correct indentation by highlighting the code and then pressing on tab button, and here we go, and then I will click Ctrl S to save the file. So now we go to the sketch file and include the header file we've just created by typing hash include my library.h. Inside the setup method we do like the previous lecture, serial.begin 9600 and then serial.println my library colon. This is the unary operator that allows us to access static methods on the class, and then I type the method name decimal to binary. I will pass the integer 134, close the brackets, semicolon, and then I will save the file. Now let's upload it to the Arduino Uno. Make sure that your Arduino is connected. Now it says done uploading. Let's open the serial monitor, and here we have got the binary for the decimal 134. Let's get back to the coding and let's open the header file once again. As you can see, the header file is starting to get jammed, just like the way the sketch files used to be in the previous lectures. So ideally we would separate the implementation of the method from the header file into an implementation file. How can we do that? Let's highlight the method body and then cut it, Ctrl and X, and over here we add a semicolon, and we can also remove the name of the parameter, and let's save. So now what we have got here, static string decimal to binary unsigned long. This is called the function signature or the method signature. This specifies the method name, the parameter it takes and their type, and the return value plus any access specifiers. You can see how clean is this when you are defining many functions on your library. So I can easily go and read the header file and use the interface you are exposing to the outer world. Now let's move to the implementation file, mylibrary.cpp, and we start by including the header file once again. Remember, it will always be included once. #include mylibrary.h, and then we define the same signature but including the body of the method together with it. So we say string and then find the class name so that the compiler knows that this method is the one defined in the class mylibrary, and then the unary operator again, colon colon, and we specify the method name decimal to binary, and then we have the parameter unsigned long value, and over here we simply add the body of the method. We've got a double curly bracket, can safely remove one, and the same above, another curly bracket. And now let's save. Let's upload our code once again. So now we have got an error saying that string does not name a type. Can you think about it? Well, remember that string with a capital S is not a built-in type in C++. It is actually a type defined in the Arduino library. How do we include it? Very simple. Let's do that. At the top of the file, let's type #include double quotes Arduino.h. This is actually where all the Arduino API is located, faced to the outer world. And let's save. Let's upload once again. Now we've got the same error inside the header file. Let's make sure that the header file has also got its own copy of the Arduino.h. At the top of the file, #include Arduino.h, and now let's save and let's upload. It says done uploading, and if we open the serial monitor, we have got exactly the same result. So let's wrap it up. First, we have created an empty sketch file and saved it, and then created two empty files in the same directory where the sketch file is located. We have got the tabs of the empty files so that we can edit them. We have defined the header file and made sure that it is included only once by using if not defined define, and then included the Arduino.h library, defined the class, added public specifiers, defined the constructor that does nothing, simply an empty constructor, and then we added the function signature to do the decimal to binary conversion. Inside the implementation file, we copied and pasted the implementation we had from the previous lecture, after including the same headers from the header file, and then adding the mylibrary, the class name, and then the unary operator so that the compiler can connect the method definition to the method declaration. And then finally, inside the sketch file, we invoked the static method on the class. So we are almost done, but not yet. Now let's open the directory again where the sketch is located. Now we can see the three files we have created: mylibrary.cpp, mylibrary.h, and the sketch file. What we need to do now is to package it in a directory with the same structure as an Arduino library. I will start by copying the two files we have just created, mylibrary.cpp and mylibrary.h. I will copy them, then I'll go to the home directory. I'll create a new folder. I'll give it a name and make sure that the name is alphanumeric and it doesn't have any irregular character or spaces and so on. I'll give it the name my_library_v July 10. I'll save it. I'll go inside the directory I've just created. I will place my source code. That's the first part. Next, as an optional step, let's create an empty text file that defines the highlighting of the library methods and classes. As you have noted here in the original sketch file, the keyword mylibrary should be highlighted in orange, just like the other methods that are defined in Arduino. That makes it easy to recognize. However, to do this highlighting, we need to specify the keywords in a text file. So again, I will create a text file inside the directory. Right click, open in terminal. You can always create an empty text file using whatever way you like on Windows or Mac. I will type keyword.text and hit enter and then X. And then I'll start editing the text file in a text editor. I will add the keywords that I'd like to be highlighted, my library, and since it is a class name, that will take the keyword specifier keyword1. And then for the method, I will give it the keyword 2, decimal to binary, and then tab. Remember, you're not allowed to use spaces, you're allowed to use tab keyword. So if you've tried to do the same using spaces, it will not work. You must use tabs. And then I'll save it. So that's one thing. We are not done yet. Let's close the file. And now let's create a new directory and we name it examples and hit enter. So when building an Arduino library, the IDE will look for examples on this library inside that directory. So let's get the sketch we have just created and copy and paste it inside this directory so that the users of our library can find a documentation on how to use the library in an easy way. So here I've got the sketch I've just created at the beginning of this lecture. I will copy it and then I will navigate to the examples directory and I will paste it inside the directory. I should give it a nice name, so I will rename it. I would say example sketch. And inside the directory, we don't need the header and the implementation files anymore. We can safely remove them and delete them. And remember, the sketch file and the directory name must be the same. So I will rename the sketch example sketch and hit enter. Now we've got the examples directory, which has got one example. We've got the keywords for the highlighting. We've got the implementation and the header files. We are good to go. I'll go up one step and then I'll right click the directory where I have located all my library files. I will choose to compress it as a zip file. Create. Now we are done. We are ready to use the library in our code. So what I will do now, I will create a new empty sketch and then I will navigate to sketch, include library, and then choose add.zip library. I will navigate to home. I will choose the directory I've just created. It shows here my library version July 10th.zip. I will choose that one. I'll choose OK. It says library added to your libraries. Check include library menu. And now let's go to sketch, include library, and then scroll down. You can see here we've got contributed libraries, my library version July 10. If I click on here, it gets included automatically in my code. Let's go to examples. Let's scroll down and here we can see the example we have just created. Let's open it. Now we can see the same example with the highlighting for my library and decimal to binary. Just a notice, in the beginning decimal to binary was already highlighted. Since I have tried the same experiment using the same name for the method, and that's why it remembers it from the last time, but in your case it wouldn't remember the name decimal to binary and it wouldn't be highlighted when you start working on this example. This was an important skill, an essential one to have in your toolbox on how to build custom Arduino libraries. This will help you package your code in a modular way and share it with your colleagues at work and even contribute to open source libraries online. Thank you and see you in the next lecture.